Hello viewers, everyone. In this video, I would like to explain about measurements. What are exactly measurements, right? If you take the measurement, first point, calorimetry is the process of measuring. It is a process of measuring enthalpy. Direct question is going to be given. How enthalpy is going to be measured? Calorimetry. Enthalpy of reactions and apparatus used is called calorimetry, right? Now, the apparatus or machine is called calorimeter, okay? So, this is going to be measure the enthalpy. Now, what is delta U? Delta U is commonly measured, is going to be measured in a bomb calorimetry. You know very well about bomb calorimeter, right? In which volume is constant. For delta U in bomb calorimetry is constant and it is represented by following equation only for bomb calorimetry. Delta U is equal to Cv and delta T. T is temperature. Where Cv, now what do you mean by Cv here? Molar heat capacity. Molar heat capacity of a calorimeter. Molar heat capacity of calorimeter. Delta T is equal to change in temperature. Whatever temperature is being changed, it is going to be measured by delta T. If delta U is known, delta U is known, delta H, it is commonly can be measured by using delta H is equal to delta U plus delta N or T. Now, delta U is equal to Z dot delta T, right? And it is capital M by small m, right? What do you mean by Z here? Z is nothing but specific heat capacity. Specific heat capacity. Specific heat capacity of a calorimeter system. Specific heat capacity of a calorimeter system, including water, right? What about delta T ma here? Delta T is equal to rise in temperature. Rise in temperature. M is equal to weight of the substance taken. Weight of the substance taken. Capital M is equal to molecular weight. I already told you now. Molecular weight of what? Molecular weight of a substance. Any substance, right? If you take the first type of calorimetry, first type of calorimeter, first type of calorimeter is used in combustion reactions, where combustion is going to happen in the combustion reactions to measure the enthalpy, right? First type of calorimeters are used. Second type of calorimeters, whatever there, second type of calorimeters are used in non-combustion, non-combustion type of reactions like dissolution of solid in water and neutralization. So for neutralization, for neutralization and solid in water and dissolution solids in water. Heat of combustion, if you carefully see, heat of combustion, whatever it is there, heat of combustion of C6H12 H5 COOH is minus 3326 kilojoules per 1 mole. Okay, there is a great scientist called Beckman. Beckman thermometer. He prepared a thermometer called a Beckman thermometer. Can be read correctly up to least 0.01 degrees centigrade. Right. For second type of calorimeter, if you take second type of calorimeter, whatever it is there, heat liberated, whatever heat is going to be liberated. Heat liberated is equal to W plus volume of reaction mixture, volume of reaction mixture into rise in temperature is nothing but second type of calorimeter. How it is going to measure the uh, enthalpy rate, that is equal to W into volume of reaction mixture into temperature. That is the common equation for second type of calorimetry. What do you mean by W here? In the above reaction, W is nothing but water equivalent, water equivalent of a calorimeter, and W is equal to M2 into T2 minus T1, sorry, T2 minus T3 by T2 minus T1 and minus M1. At last, where T2 is higher temperature of known mass, T2 is equal to, it is higher temperature of known, it is a known mass indicated by M2. Whereas what is T1 here? It is the lower temperature. Arrow mark indicates lower temperature, right? And lower temperature of mass M1. And whereas T3 is equal to resultant, the total resultant of a temperature. So these are the specific terms given in the equation. Heat evolved is also calculated by the following equation. In a specific system, heat is evolved, right? If heat is evolved, heat is evolved, it is going to be calculated by Q equal to capital W into small m into S into T2 minus T1. Now the point is, in this entire equation, all the terms you know very well. Otherwise, you can cross check right now. Q equal to heat of reaction, heat of reaction. W is equal to water equivalent of water equivalent of calorimeter, whereas M equal to mass of liquid, M equal to mass of liquid in the calorimeter, S equal to specific heat of the liquid, specific heat of the liquid, it is indicated by S. Whereas T2 is equal to final temperature, T2 is equal to final temperature, T1 is equal to initial temperature, initial temperature, right? The reaction enthalpy, standard enthalpy of reaction, I would like to discuss with you, right? What do you mean by reaction enthalpy? Let us take a reaction enthalpy. For heat evolved, we have a separate equation, right? Now, if reaction enthalpy, how reaction enthalpy it is going to be checked. Reaction enthalpy delta R is equal to capital H, right? It is the enthalpy that change in a reaction when the number of reactant moles are as per the stoichiometric equation. Okay, when number of moles are according to stoichiometric equation, then the delta RH it is going to be measured. Delta RH is equal to, right, BIH M mass of nothing but product, right? And in the similar manner, in this symbol, AI capital H M is nothing but reactance. In both the cases, you can check AI capital HM, BI capital HM. These two are equal now, hence it is called the reaction enthalpy. AI, BI are the stoichiometric coefficients of the reactants and products. Whatever you are seeing here, AI here, BI is here. What are they called? Coefficient values. They are called coefficient values of standard stoichiometric reactants as well as products. To indicate reactants and products according to stoichiometric standards, coefficient values AI, BI, A small I, B small I, coefficient values are going to be are indicated with them. Standard enthalpy of reaction. If you take standard enthalpy of reaction. This standard enthalpy of reaction, how it is going to be indicated? Delta small r H power theta. Okay. It is the enthalpy of the reaction when all the participating substances are in their standard states. All the participants in a reaction are participating substances. Whatever product reactants, let us take reactants in a reaction. They are called they're going to be participant, right, in a reaction in their standard state. In their standard state, right, which is known as a standard enthalpy. Standard in the sense it will be not changed once it will not be changed and it depends upon the reactants. That is the reason why it is called standard. The standard state of a substance at a specific temperature is its pure form at a 1 bar pressure. So what do you mean by standard enthalpy here? I told you, right? But here you have to learn one more thing. Standard state of a substance, whatever standard state of a substance is there. This standard state of a substance at a specific temperature, at a specific temperature is going to be pure form at a 1 atmospheric bar pressure or 1 bar pressure. At 1 bar pressure, standard state of a substance, it will be in a pure form, which is generally gives standard enthalpy. Clear? So what are the various types of enthalpy changes? We are going to learn in the next video. Until stay tuned. Thank you. Have a nice day.